All right. So why Iceberg? Why do we even want to do this? There's lots of content out there. The last couple conferences, Snowflake and Databricks kind of wrapping up this week, talk about Iceberg. But what is it? So Iceberg at a high level is an open table format for storing data on object stores. And that standard is a way for you to easily create and update and also optimize large analytics tables on these object stores, something that was possible in Hive, but was very difficult, right? You had to write a lot of extra code to be able to do it in a safe manner. So again, the common use case that you see for Iceberg tables is insert, update, and delete. Primarily change data capture streams coming from a database. I want to write it into a table in S3. In Hive, that's hard to do, right? You can insert very easily, but to update and delete, extra work that you have to do, and it's not very safe, meaning that it's not within a transaction. There's not any kind of isolation when things are happening. Asset transactions, something that we have in databases, would love to see and have in the lake. So that's possible using Iceberg. Schema evolution has traditionally been a difficult thing to handle. Iceberg makes it a lot easier, and we'll talk a little bit about how that's done. Iceberg calls this hidden partitions. I call it dynamic partitions, but in essence, in Hive, those are static partitions that you create in your object store. In Iceberg, these are all metadata-based partition definitions. It's called partition spec. You basically say, this is how I want to partition my data, and then it's recorded in the manifest, but it's not statically defined in your S3 bucket, right? So if you want to change it later on, you don't have to rewrite the data or move it from one bucket to another. Pluggable data store format. So today it's Parquet, Avro, and ORC. In the future, there'll be more, right? Puffin is one that's coming up. There's others as well that are popular. But again, it's a decoupled storage layer from the table layer. So that makes it easy for you to slot in different storage formats as those evolve. And then storage optimization, something that traditionally has been difficult to do in Hive data lakes. Now it's built in as built-in functions inside of the Iceberg library that users can just run and say, optimize my storage, compact my data, delete data that's no longer being used, et cetera, et cetera. And we'll get into some of that detail in a little bit. So those are kind of the big features, I would say, or capabilities that users are going after to say, that's why I need to move to Iceberg. So Iceberg as a table format, it's part of a bigger vision. This vision is what I call the shared storage vision, as a way of saying, hey, I need a standard way to store and catalog my data in a way that's easily accessible from any number of systems. So again, you heard Snowflake and Databricks making a big commitment to Iceberg. AWS, all their analytics services support Iceberg, BigQuery, Azure Fabric, Salesforce also recently talked about integration with Snowflake with regards to accessing Iceberg tables. So the ecosystem is expanding faster than we can count. But what the benefit here is that all of those tools don't have to build custom integrations. They don't have to build custom connectors or have some weird configuration to access data. Everything is standard. So from your perspective, you store the data once, you ingest the data, you store it once, and all these tools can access it. They can both read and write to it depending on the permission that you give. So that's a really, really powerful sort of vision around shared storage. Now, if you take a step back and you look at the 30,000-foot view, shared storage, actually, it's a bigger part of an open decoupled lakehouse architecture. And I'm not going to go into a lot of details on what lakehouse is and why it's different, but in essence, you have on the bottom, you have the shared storage, right? So that's Iceberg, and then the storage layers on AWS, Azure, and Google. And above that, kind of like the purple and bluish, those are the compute engines. That can be Spark, Databricks, Snowflake, AWS Redshift, whatever that may be, whatever your use case is. And then in the middle is that catalog layer, the thin catalog layer that connects the two together, right? So there's no more a need to duplicate data. All these systems know how to read it. And the data itself is already optimized. The data itself is already updated, or if you have to delete rows or the security on top of that, all that stuff is handled independently. So you don't have to replicate or duplicate efforts depending on what compute engine you're using. And that's the really, really powerful model to decouple, truly decouple the access and storage of data from the compute layer.